So if you kind of think about the hand-waving definition of continuity, continuous means that you can draw it without lifting your pencil. And so if you look at the absolute value, you know that you can draw this without lifting your pencil. So I am perfectly fine with you just saying that it's continuous on, and in this case, we're looking at the interval -1 to 1. And that is just kind of understood by properties of absolute values. All right, now the second thing that we have to talk about is the differentiability question, and it needs to be differentiable on -1 to 1. All right, now to answer that question, I'm going to go over here and just kind of have a side note conversation. So differentiability is about, is the function smooth? Now, if you think about the absolute value of just x, you know that the absolute value of just x is at the origin, you have the lowest point, you have the corner, and we would say for the absolute value of x that f prime of x does not exist at that corner. Now, more specifically, we would want to know where that corner happens. And that corner happens when this quantity x is equal to 0. So f prime is it does not exist at the corner, x is equal to 0. So if it was just absolute value of x, we would say that f prime of 0 does not exist. Now, you can actually kind of generalize this for all different absolute values. So if you were to look at like x plus 1/2, for example, what that would mean by transformations is that you have shifted this horizontally to the left. And if you think about what would happen if you shifted horizontally to the left 1/2 units, what would happen is the corner that's at 0 would now be at -1/2. So you would have to say that this function is not differentiable at -1/2. All right, so you can again generalize this further. So anytime you have something inside this absolute value, it is not going to be differentiable when or if whatever is inside that absolute value is equal to 0. And if you just kind of quickly look at this x plus 1 to the, or x plus 1/2, if I were to set that quantity equal to 0 and solve, I would get that x is equal to -1/2. That's the place where we have our corner. So that is what we need to do in this question 167. So in question 167, we have an absolute value, and that is very concerning because the corner will happen when whatever is inside this absolute value, namely x minus 1/2, is equal to 0. So if I solve, I get that the corner happens at x is equal to 1/2. Now, that may or may not be a problem depending on what type of interval you have. So in this case, we are interested in the interval from -1 to 1, and it is a problem for us because we see that that corner lies within the interval of interest. So what we would have to say for this question is that the mean value theorem does not apply because f is not differentiable on -1 to 1. And specifically, there is a corner at x is equal to 1/2. So I really want you to realize that when you have this absolute value, you have to be super careful about where the corner happens. And sometimes it's a little bit more involved to figure out where the corner happens. But when you just have a horizontal shift like we have here, it's going to happen when that quantity inside of the radical is equal to 0. And so in this case, the corner happens inside of the interval, so we have to say the mean value theorem does not apply.